Yes, I'm ready. Anyone would like to pick? Should we illustrate with x to the fourth or x to the fifth and then with a log?
Yes.
Would you like to start with the log or you would like to start with the polynomials? You choose.
Polynomial and the log.
Okay, very good. So let's start with 84, which is f of x equals 2 minus log base 3 of x plus 1. What is important here is to remember order of operations. What do I mean by order of operations? Imagine that as if you are evaluating the function. So if I evaluate the function, this is what I have to do first. Then, because it's log, right? It's log base 3, that's the base function. So log base 3 of x is the base function. The first transformation will be log base 3 of x plus 1. The next one will be this minus. So if I evaluate the function for 2, I have 2 plus 1, which is 3, and I apply log to it. Then I have to multiply by -1, and then I have to add 2 to the answer. That's the correct order of operations. You cannot do 2 minus this. No. If x is 1, or 2, whatever, if x is a number, you put the number in, you add 1. Then you apply log to this. When you're done, you multiply by -1. When you're done, you're adding 2. So this is the correct order of operations. So then the next one will be negative log base 3 of x plus 1. And finally, the last function is 2 minus log base 3 of x plus 1. I have to show all these graphs. The graph of log base 3 of x, the graph of log base 3 of x plus 1, the graph of negative log base 3 of x plus 1, and the graph of 2 minus log base 3 of x plus 1. I decomposed this function into 4 steps. The base function, the shift to the left, the reflection, and the upshift of 2 units. Do you need me to repeat this before we graph them? Do we need to repeat this before we graph them?
Yeah.
So, in order of operations, as if, let's say, I'm going to erase this. Let's say I want to evaluate the function for 3. This is my first step. I have to perform this, right? And then I apply log to it. When I'm done, then I have to multiply that number by -1. And after I'm done, to that number that is already multiplied by -1, I have to add 2. So these are these steps. First, I start with the base function. How do I know the base function? It's log base 3. That's the base function. Then x plus 1 will shift the graph to the left, 1. Then the -1 in front of it will reflect the graph, will flip the graph with respect to the x-axis. And this one will move the graph, will shift the graph up 2 units. So, first I graph log base 3 of x. Log base 3 of x. This is done. The next step is shifting 1 unit to the left. Remember, this is the so-called vertical asymptote, x equals 0, of this function. If I shift this graph to the left 1, the vertical asymptote must shift 1 unit to the left as well. Actually, it shifts first. So So this is x equals -1. This point moves here. So this is the new graph. What graph? Log base 3 of x plus 1. So this is done, this is done. Now I have to reflect. How do I reflect? Very easy. Just reverse with respect to reflect with respect to the x-axis. So this is negative log base 3 of x plus 1. Final step, shift the green graph 2 units up. 2 units. So this point moves here. And this is final graph, which is 2 minus log base 3 of x plus 1. Is this accurate? No. No. The shape is perfect, but is it accurate? No. I don't know where the function crosses the y-axis. I don't know where it crosses the x-axis. I have to do the algebra to determine that. But the shape is absolutely perfect. Do I know the domain? I do. From -1 to infinity, right away. -1 to infinity. Do I know the x and y intercepts? No. This is just a quick graph, decomposing it step by step, so I can graph it and I can have an image immediately. Is it easy to check? Yes, it's very easy to check, and we will determine algebraically in just 1 minute. So at any point in time, you can always use y equals, and we had 2 minus. There is a problem with log base 3. I don't know if this calculator has, does it allow us to put log base 3? Ah, it does. Look at that. Look at that. Brilliant. Thank you. Okay, and x plus 1. That's the graph. If you want to see each piece, then you have to put all 4 functions, one by one. If you only want to see the final one, the shape has to be 100% what we have, but the x and y intercepts were not determined. So I will use zoom 6. Here it is. Very tempting to copy something like this, and you know it's incorrect. You know the graph does not start here. It goes all the way to positive infinity. Now, we know there is an x-intercept somewhere here. There is a y-intercept somewhere here. And we will determine them in a blink, algebraically. It appears that it's at 2. It appears that it's, I don't know, 2, 4, 6, maybe 7. We'll see in a moment. Okay? But, again, be very careful. Do not copy something like this. I know it's tempting. So, if we want to determine algebraically what you just told me before, f of 0, very easy. 0 plus 1 is 1. Log base 3 of 1 is 0, so the answer is 2. So 0, comma 2. I was way off. 0, comma 2 is somewhere here. So the graph should cross. I'm not going to make any changes here because it's going to be confusing, but you can go back and graph the function again correctly. But that's what transformations are for. A quick graph so I can see the shape. If I want to determine the exact x and y intercepts, I have to do more work. Okay, and f of x equals 0. We have 2 minus log base 3 of x plus 1 is 0. We move to, maybe this one is easier, or it doesn't matter. If when I move log to the other side, I can read the problem from the other. It doesn't matter. And remember how we change this. Anyone remembers the equivalency? The base 2 equals the number. So 3 squared is 9. So x plus 1 equals 9, so x equals 8. So 8 comma 0. Yes, I was way off. So the x...
Where did the negative go in front of the log?
So when I move this to the other side, both of them are positive. And I can rewrite it from the right. So in other words, I'm saying you can write x minus y equals 0, which means x equals y. Or you can write y equals x. They all mean the same thing.
Okay, thank you.
So the negative sign makes, when you move this term to the other side, becomes positive. But you can also choose to read the equation from this side. Is that better?
Yep, thank you.
Thank you. So now, perfect shape, but not perfect x and y intercepts. So the graph should be something like this. If you want to be exact now, we can graph it. Because now I have the details that I did not have before. So, 0, 2, 1, 2, 3, 4, 5, 6, 7, 8. Here's the graph. This is not a straight line. It's just that I have to stretch it a little bit to get there. It's not a straight line. So this is f of x, 2 minus log base 3 of x plus 1. Any questions? Any questions about transformations? Any questions about transformations? Please don't be shy. Let me know if you need more examples. Do we need more examples on transformations? Do you want us to work on any of the 4th degree or 5th degree?
Yes.
Very good. Please choose. Anyone would like to choose 4th degree or 5th degree?
5th degree.
Okay. 41 then. So f of x equals 4 minus x minus 2 to the 5th power. Okay, perfect. Again, we have to remember how the 5th degree looks like. We only looked at the 3rd and the 4th. We did not look at the 5th. But the 5th cannot be that different from the cube. We did not list the 5th degree. But we did have the cubic function. So this was the cubic function. I don't know if this is a good color. I don't think this is a good color. So let me try a different color. So we had x cubed. How will x to the 5th look like? Very similar. Even flatter here. It takes longer to go through the exit to the origin. I'm going to exaggerate. Don't assume that these are 10 million solutions here. No, 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 no. It just goes slower till it finally crosses. So this is x to the 5th. This is the base function now. So now I have x minus 2, which will shift the graph in which direction, how many units? Which direction, how many units?
To the right too.
Yes, awesome. Very good. Thank you. Who was that, Kevin? Okay. So it's right here. So now the graph, I'm exaggerating as much as I can. So at 2, so this is x minus 2 to the 5th power. Good. So this was the first step, x to the 5th. This is the second step, x minus 2 to the 5th power. Now I have to reflect it, exactly like we did with the natural log. I mean, with log base 3. I have to reflect this graph. Okay, let's reflect it. Okay, I reflected it. And what will be the last step? What do I have to do to this purple graph or indigo graph? What do I have to do to it now?
Shift it up 4.
Exactly. 1, 2, 3, 4. And that's final. Do I have an idea about the x and y intercepts? Absolutely no clue. If my life would depend on it, I would not, till I do the algebra. This is final. What final? F of x equals 4 minus x minus 2 to the 5th power. It was quick. I graphed x to the 5th. I shifted it to the right 2. I reflected the graph and then shifted up 4. It was a quick graph. Do I know what this is? No. Do I know what this is? No. But the shape is carved in stone, for sure. That is it. I used transformations. I applied them in the order of operations. This must be it. Do I know this point? Yes, this one I do. It's 2, 4. There's no question about it. This one, no clue. This one, no clue. But not a big deal, because I know I determined this one with f of 0, and I determined this one with f of x equals 0. So let's do that. And that's my page 9. I'm going to copy the function here. 4 minus x minus 2 to the 5th. So let's find f of 0. 0 minus 2 is negative 2. Negative 2 to the 5th is negative 32 plus times negative 1, positive 32, 36. So 0, 36. I had no idea. I have no idea that this is 0, 36. One more time. 0 minus 2, negative 2, negative 2 to the 5th, negative, am I correct? Negative 32. And negative 32, negative 30, positive 32 plus 4, right? 2 to the 5th is 32. Okay? Good. So I had no idea. Now, what about this? Well, I have f of x equals 0. So we have 4 minus or equals x minus 2 to the 5th. And I have to apply the 5th root. So I have x minus 2 equals the 5th root of 4, or x equals 2 plus the 5th root of 4, which I have no idea. I had a calculator. Here it is. So I have 2 plus 4, and I like the power 1/5. I got 3.32. Is this in my graph 3.32? Of course not. Of course not. So we can go back and graph this to make sure that the shape, which is very clear, is what we just got, but let's see, 4 minus parentheses x minus 5 No, x minus 2. X minus 2 to power 5. Now I know that I have to go as far up as 0.36 and pass. So the window, it can start at -4 if you want, but it has to go to at least 50. The scale 5. I'm sorry, I was thinking of, sorry. Okay, so -4 is okay, maximum 6 is okay with a scale of 1. We're talking about x. Now we're talking about y. So -4 and then pass 36 with a scale of 5. So when I hit enter, I have to see the graph we graphed and the intersection at 0.36, and it will be hard to see that 3.32, but we'll see what happens. Okay, so right here, this is 0.36. Right here, this is 3.32, 0. It doesn't look like it's the same, but it is absolutely the same because the numbers are different. So that's the use of transformations. Not to get a perfect graph, but to get a perfect shape and quickly. Determine the shape quickly. Any questions? How do you feel about these transformations? Do we need to work on these more, or we are okay? Anyone please say something? How do we feel about transformations?
I feel okay.
Thank you. We're going to practice some more when we review. So I'd like to go to this handout now. How we divide polynomials. We may not be able to finish in 15 minutes, obviously not, and I want you to work on an easy problem in a minute. But at least how to divide polynomials. So division of polynomials. Division of polynomials. Okay. So we can go through all these. For a moment, I just want to present a couple of things here. If we have a polynomial divided by one term, also called monomial, then the situation is like this. Let's say I have x to the 4th minus 3x squared minus 4x plus 7 divided, let's say, by x squared. Any polynomial divided by one term. Allow me to start a new video 1 second because I passed 23 minutes. Sorry.